Kia ora koutou, nau mai haramau, kohini tito tokungawa. Kia ora, welcome. I'm Heni, your first time MC today, and it's my it's my absolute pleasure to introduce our first speaker in this track 2. Thor works for Objective, and we'll get straight into it. Pass it over to you. Big round of applause. Welcome, Thor.
Test. Good. So yeah, good morning, coding fans. Welcome to my talk. I'm Thor, a passionate developer who wants to share some experiences, findings, opinions about mocking. So today my topic is build a mock API server that feels real with MSW.js. In this talk, I plan to go through the content, including why do we need mocks, and what is MSW, and why should we use it. Beyond that, I will also demonstrate a minimum setup with React application and discuss how to make mocks feel more real and becomes more maintainable. Okay, let's get started. Oh. Okay.
Oh, yes. Might be a dodgy cable.
Dodge.
Yes, we're done. All right.
Do I need to start again? No? Okay, cool. So in this, so at the very beginning, you might ask, why do we need mocks? So from my point of view, we could categorize the reasons into 3 perspectives: development, testing, and debugging. So let's look at the first one, development. We have several points here. So on the one hand, most of us many times may not have the luxury of developing a front-end against a ready-to-use backend. That is, we may need to develop front-end and backend in parallel. Using a mock server would empower us to start developing the front-end immediately rather than waiting for the backend. On the other hand, sometimes we want to express our needs to backend fellows, such as expressing what we want from the payload with a specific format or something. Then having a mock server becomes a very self-descriptive solution that is easy to communicate and understandable by both parties. Apart from the reasons above, when the whole team collaborates on UI UX, we probably could to have a runnable demo is much better than just having wordings and images. With a mock server, we can deploy a determinate playground version of our app that is safe to play with and has no effects on the real data. They are the reasons of using mocks on development. So when looking at the testing, which is also a big part of our daily practice, I feel that the web apps nowadays are becoming more and more complex, and we need to write smarter tests to cover the user's behaviors. If you are already using some modern testing frameworks, such as React testing library, you probably already heard the famous quote from the Chen, saying that the more your tests resemble the way your software is used, the more confidence they can give you. So traditionally, we probably would only targeting at mimicking your real user's behavior in end-to-end tests. However, they are not easy to set up, and they are slow to run. Now, with a good mocking server, we are able to write unit and integration tests within the front-end boundary without hassle. Another bit I would like to mention is debugging. We all faced some scenarios that a bug or issue can only be reproduced against a very specific API response. Having a mock server allows us to easily reproduce the API response instead of trying to trigger it manually with a real backend. We could then include the specific case in our test afterwards after we're fixing the issue. This is more of a conjunction of development and testing. Sounds quite useful to have a mock server. Then what should we do to enjoy all the benefits? Let me introduce you a library called MSW.js. MSW stands for Mock Service Worker, which is an open source API mocking library that uses Service Worker API to intercept network requests. I'm not going to dig deeper on the concept or details of Service Worker. we could just recognize it as a script that runs in the browser, and it is separated from the main application. The image on the screen briefly explains how MSW works. That is, the application sends the network request, and it then intercepted by the service worker, and then passed to MSW. Internally, MSW is trying to match the request to some mocking logic, and then return a mocked response. Beyond all the benefits of having mock server, mocking with MSW brings us more power on the table, such as seamless integration, which means the application code will not need to know whether the backend is mocked or not. Real backend behavior, for example, we can return responses dynamically and persist data even in the mock server. Reusable in different contexts, that is, we can use the same mocks for development, testing, and debugging. Inspectable, which means we can inspect the ongoing network request via browser step tools while using a mock server, which is very handy when developing and debugging. Also, we would have a dedicated layer to intercept the request, which contributes to the better maintenance of the mocks because they are centralized and can be managed in a single place. Now let's walk through a minimum setup with a React application to get a closer look at it. Imagine that we have a new application initialized by create React app, and we are using TypeScript. What we are going to do here as a first step is just to install the MSW as a dependency and run a command to initialize it. As a result, a new file will be created under the public folder named as mockserviceworker.js. This is the starting point where the magic happens, and we are not supposed to change this file manually. Then, let's create some files manually. Under the src/mockserver folder, we could create 3 files: handlers.ts, mockserver.browser.ts, and mockserver.node.ts. I will explain what we should put in those files in a moment. First, let's look at the handlers.ts file. This is a file we put all the request handlers and response resolvers. I would probably need to give a little bit more explanation to the concept of these 2 terms. Response resolver is a function that accepts a captured request and returns a mocked response. For example, from line number 5 to line number 11, we define a response resolver that just returns 200 with a JSON payload, including ID and name. And request handler is a function that is used to match and intercept the URL and pass it to a response resolver. In line number 14, we define a request handler that will intercept the HTTP GET request accessing /API/me and pass it onto the response resolver we just created. At the end, we collect all the handlers and export them for use later. A quick note here is that the handlers and resolvers are usually shared in both browser and Node.js environments. Then, in mockserver.browser.ts, we just set up a mock server instance with the handlers we defined before and export it. The last step we need to do is just to make some minor changes in the entry file of our application. Here, we dynamically import and run the mock server under the development mode, and this is how we could make the mock server start to listen and intercept the request from our application. To prove that the mock server is really working, let's add some code in the application to actually send some requests. Here, we use a fetch API to access the endpoint we just mocked, which is /API/me, and display the return result as it is. So let's see what happens when it runs. Hello world. OK, so the left side shows the running result of the minimum app. And the right side shows the request log using the Chrome step tools. As marked in the screenshot, Chrome knows that the request is responded from a service worker, and it knows the response is powered by MSW. Hopefully, you can see it clear, or I can show it in a larger version when I demo it. So also, if we check the payload, we can see a JSON that contains ID number 1 and the name with string world. That's why we see hello world in the left side. So far, so good. So now let's take a look at the testing side. Similar to what we did for the browser environment, we just need to set up the mock server, export it, and make some minor changes in the setup test file. The changes we need to make are, before running all tests, we start the server, and after running all tests, we stop the server. And after running each test, we reset the handlers. This is to reset the one-off overwriting, which we might not cover in this talk, but we need to add this line. That's all the setups we need. Let's jump into some testing code. So in this minimum test case, we simply render the app component and check if the hello world text is rendered. Remember, to make the text rendered as expected, the network request should happen, and the result must be correct. Guess what? The test passed. All the code is on my GitHub, so you could clone it and have a play on your own. Beyond the very minimum setup, I would like to have a bit more complex demo, which is a to-do list. That would help us to understand the rest of the content I would like to present. First, let's have a look at the demo application and what it should do. Well, basically, it can fetch, create, delete, toggle, and filter the to-do items. And based on that, we have imagined 4 REST API endpoints. They are get, post, patch, and delete. So now it's a live show. So this is my very basic to-do list demo application. Let's refresh the page to start. OK. So when the application is loaded, we can see that there is a list of pre-existing to-do items that's being displayed. If we have a look at the dev panel, we could see that there is a GET request to fetch the to-do list. And let's inspect it. And we can see that it returns a list of to-do items, which includes a to-do 1, 2, 3, as displayed. Now let's try to add some new to-do item. So for example, if we just add one new one, enter, and see we can instantly look at see that there is a post request being logged in the DevTools, and let's inspect that as well. So from the request payload, we could see that the request body contains the description of the new to-do items, which we just entered. And let's look at the response. The response looks OK as well. It has a correct description. It also has a correct completed flag, which is not completed. And it has an ID, which is number 4. OK, let's try to add another one, which is new 2. Another post request being logged. And if we look at the response, oh, ID number 5. So it feels like the ID is auto-increased, right? So now let's try to toggle a to-do item. So for example, if we just toggle the new 2, which is created, we could see that a patch request is being sent. Let's also inspect that. In the request payload, we could see that we express the intention that we want to set the completed flag to true. And from the response, the server seems to tell us, yes, the to-do item has been marked as completed. Now let's try to filter to-do items by switching tabs. So if we click active, we can only see the not incompleted to-do items. And if we click completed tab, we can only see the completed to-do items. I would like to mention that when switching tabs, the app will always send requests to fetch the filtered list for demo purposes. If we look at the DevTools, we could see that there are 2 GET requests being sent with very different query strings, one with status equals active and another with status equals completed. Well, let's inspect one of them and see, for example, the completed one. We could notice that only the completed to-do items are being returned, which means that the list is actually already filtered. OK, let's try to delete some to-do items. Let's still delete the new 2. See, the delete request has been sent, and the 204 response has been returned. And also, if we click all to refetch the whole list of the to-do items and inspect the result, the new 2 is gone. So it's not included in the payload, which is expected. So far, all the operations are performed successfully, but we could also try to simulate an error response. So for example, if we try to delete the to-do 3, see, 400 is returned when we send the delete request, and the error message is displayed. So that feels quite normal for an application and nothing fancy at all. But what if I tell you that all the network requests are responded by a mocking server living in the browser, and there's completely no API backend for this application? Let's inspect the request using the dev tool and check the header. For example, this one. If we check the header, you will see something here that the Chrome knows this response is coming from the service worker, and it is powered by MSW. And if we just refresh the page, we could see all our changes are gone. The demo is deployed online, and the code is also on my GitHub, so feel free to try it. OK, let's back to our slides. As we see, the to-do list application can consume 4 API endpoints, so it does not have a big issue on managing the mocks. However, imagine that when developing a much more complex application, and we would have a much larger number of API endpoints to call and mock. In this case, keep mocks maintainable and scalable becomes a challenge. I did some experiment, and the outcome works well for my project, so I'm just going to share some of my findings here. So the basic idea is to organize response resolvers based on file paths. Yep, just like nz.js, but a little bit of variation. So if we want to write a resolver for the get-to-do items endpoint, we could place it on /API/todos/get.ts. And then if we need a path parameter, we could just add brackets around it in the file path as a folder, such as /API/todos/bracket_id/delete.ts. By taking this approach, we could find, change, refactor, or move a resolver much easier, even if we have dozens or hundreds of endpoints. Also, it helps us to keep consistency across response resolvers, such as using a consistent name for a path parameter under the same group. Built on top of the basic idea, we can now automatically create and register the request handlers based on our response resolvers because we have followed a rigid pattern of organizing those files. Assuming that we are using Webpack, the trick here is to utilize require.context to scan and import each response resolver according to our pattern. I will show you a working example. So we could write a function that returns a resolved handler, and inside of the function, we could just scan the resolve folder and grab all the .ts files following a specific naming pattern. And then we iterate through the imported paths we just found, and we import the resolver, and we detect the API paths, also detect the HTTP method, and finally generate the handler. Again, you can find more details on my GitHub. A quick note here is that the require.context is not available by default when running tests on Node.js, so we need to polyfill it. Luckily, we could find some examples from the internet, and it's not hard to tweak and modify. OK, we have achieved a lot with the ideas of making mocks maintainable and scalable. Let's move on to the next chapter, make mocks feel real. So the motivation is that we are not really satisfied with serving just the static data for every single request. And we want the mocks to feel real in order to maximize the benefits of mocking. As shown in the to-do list demo, we can make the mock server respond dynamically based on the request information, and we can persist data as well. That is, we can make the mock server just like a real backend server running in our front end. Let's talk about the dynamic response first. As we can see, when responding to the GET request for a list of to-do items, we can extract the filter information from the search parameter or query string, run the filter logic, and return a filter logic list based on that. When responding to the patch request, we can grab the ID from the path parameter to determine which to-do item we are going to modify. Also, we can read the payload from the request body and then perform further logic upon that. It is very similar to an Express-powered Node.js server program. Apart from the dynamic response, another crucial part of making mocks feel real is to persist the data, which is quite interesting in the context of mocking server. The basic idea is to build a simple in-memory data storage solution which can be easily accessed and reset. MSW does not provide such a thing out of box, so I got my own solution inspired by the standard storage API. So here is the interface of each data storage, assuming that there is an ID for all data we want to store. That is, I have a store to hold actual data, and then we can perform CRUD operations such as get item by ID, get all item, set item, add item, and delete item. I also added reset and get next ID for convenience. Then I built 2 classes implementing the interface, one for data with number ID, another for data with string ID. When writing a concrete data storage class, such as to-do data storage, I just extend from a base data storage class. Yep, just extend that, and calling the reset method in our constructor and fully initialize it. And inside the reset method, I clear the data store and reload all fixtures. A minor point I would like to mention is that I prefer to use TypeScript here as well, so that the fixture data can also be strongly typed. Then I create an instance of the to-do. Then I created the instance of to-do data storage and make it part of the mockdb object. That is a holder of all data storage instances for anyone who wants to use them. I also write a function that to reset the mockdb, which literally just iterates the data storages as it's holding and invokes the reset method. Usually, I would like to expose the mockdb globally for debugging purpose as well, so that I can easily access it in browser's console. Once we have done all the setup, we can start using our simple data persistent layer. For example, we can load to-dos in the resolver of get endpoint by calling mockdb.todos.getItem, and create a to-do by calling mockdb.todos.addItem, update one by calling getItem, get a single one by getItem, and update one by setItem, and delete one by deleteItem. So far, as long as we made all those setups, we can already reproduce what I have seen in the to-do list demo. Well, from the test side of things, we can also use this data storage, which can not only provide us a complete set of fixtures, but also help us to keep server state persisted during a certain session or business flow, so that we can test some multi-step scenarios as well. A quick note here is that we need to reset the mockdb after running each test to guarantee that the state of each test is clean and determinate. It is very simple to do so, just one line to write. That is, when set up tests, we call reset mockdb in after each. Now we can have fun with all the green ticks for tests that are powered by our mock server, and we are mimicking real users' behavior without need to sending network requests outside. Apart from the basic data persistence needs, we can also handle data relationships with this solution. For example, imagine that we want to add assignees to to-do items, which means we want to add a many-to-many relationship between user and to-do. We could firstly create a user data storage with a fixtured user data, and then we could create an assignee data storage to store the relations between to-do and user. Here, we could follow the dependency injection pattern to pass a to-do data storage and user data storage into the constructor of this relation data storage. Then, we can add some fixture relations, normal and simple. We can also add some additional methods if we want. After that, when setting up the mockdb, we could initialize and hold all 3 data storages on mockdb. To make our life easier when serializing the response payload for each to-do item, we could create a helper function to unify the serialization process and embed the information of the assignees. Then we could easily reuse it in our response resolver. For example, in the resolver of get to-do items, we could just map the filtered to-do items and to apply the new serialization process, which should add assignee information. As a result, we can see the payload return from the get-to-do endpoint does include the assignee's information. While preparing this talk, I noticed that there is another library was just released to help manage mock data for MSW, which is called MSW.js/data. I had a quick look, and I find it looks very similar to Prisma. I haven't tried it yet, but it may worth a look if you like the Prisma way of querying and managing data. There are so many things to talk about mocking with MSW, but we cannot cover all of them. You could explore the official documentation and to find more interesting topics, such as response patching, mocking binary response type, one-off resolver overwriting, and compared to other tools. No tool is perfect, neither does this one. I find some gotchas when using it, which I would like to mention. First one is the support for HTTPS. This is more of a limitation of utilizing Service Worker API for security reason. That is, you can use it with localhost domain with both HTTP and HTTPS. However, if you want to host your frontend with a mock server online, for example, the playground for UI UX, it can only be served with HTTPS to enjoy all the benefits of MSW. If it's not served with HTTPS, MSW will work in a fallback mode, which does not use the service worker, so you are not able to inspect the network request using the browser step tools as we show in the demo. My workaround is to host it with AWS S3 with a CloudFront to provide the HTTPS. Another gotcha is that there's no concept of middleware when writing the resolvers. However, we can encapsulate the middleware logic using a high-order function to wrap the resolver. For example, if we want to mimic the enforcement of authentication protection on a group of endpoints, we can create a high-order function to do so. We might be able to call it high-order resolver. So many thanks for listening, and hopefully there are some takeaways for most of you. And also, I would like to mention that my team is hiring. We are located in Palmy, and we want a senior front-end engineer and a senior Java engineer. And our company is named as Objective. So feel free to reach out if you think it's not a bad idea to work with me. So now it's the question time, and you could also reach me in person afterwards. Yeah, thanks.
We've got time just for a couple of questions. So just put your hand up and we'll bring the mic over to you.
Hello. Any production system I've worked on where we've set up a bunch of mocks, they always get out of date quickly whenever the backend changes. Do you have any tips for, like, in a team, like helping them stay up to date?
So you mean your team, like the backend change frequently, and you want to keep your mocks up to date with them?
Yeah.
I think it's more of a communication thing that you just keep communicated with them, and if we want to enjoy all the benefits, we definitely also need to align up with their changes as well. So I think that's the effort we need to do to enjoy all the benefits.
Thanks.
Yeah, it's more of a communication.
Another question?
Hi there. Have you tried using this with GraphQL?
Sorry, could you say?
Have you tried mocking GraphQL requests?
Well, the official documentation says it supports, and I haven't really tried this. I believe there are other tools to mock GraphQL API as well. So to be honest, I didn't really try using this one to mock GraphQL. It supports, but you can have a go. But for this talk or for my daily life, I'm more focused on just the REST APIs. So yeah, have a look at their official documentation. It does give you some guidance on how to achieve a mocking server with this tool for GraphQL, and do explore other solutions as well. I think Apollo server also has a mocking solution. So yeah.
Thank you.